Hi, I'm Mark Fisher with Lincoln Electric's Advanced Technology Products Group. I'd like to discuss HyperFill opportunities, where and how to successfully apply them in the field. First up, we'd like to discuss weld size. Fillet and groove welds in position 1G, 1F, 2G, and 2F. Flux core will allow for a 3G and 3F position. 5/16 or 8mm 2F multi-pass fillets and groove are what we're targeting specifically. We can hit a 1/4 inch weld size or 6mm. It is possible, but that's not what we're specifically targeting HyperFill successfully for in the field. Adequate weld length is another target that we want to consider. The weld length should be greater than 2 inches. We can tack with HyperFill, but for the most success, better output, reduced cycle time, we want to see a minimum of 2 inches in weld length. General guidance for successful implementation for HyperFill. We'd like to cover a couple of these finer topics. We want to ensure that we have good cables capable of carrying high amperage from the power wave to the robot. Proper fixturing also needs to be a consideration. We're looking at high amperage. The robot's moving faster travel speeds. Proper weld size is also a target. 5/16 fillet welds, anywhere you see them. This is where we're targeting. In a 2F position, in a 1F position. We can hit 1/4 inch material. If there's some 1/4 inch welds to be had, yes, we can target them. We're not specifically looking for a 1/4 inch weld or 1/4 inch material. Circumferential welds, also. As long as our diameter is 3 inches or greater, such as an axle, we can also hit these circumferential welds without any concern or issue. Programming with HyperFill is exactly the same as any single wire process, and we remove all of the limitations that we previously had with tandem MIG. There's no concern about orientation. For more information on Lincoln Electric's extensive portfolio of welding and cutting products, please visit lincolnelectric.com.